We're going to learn three things today. Remember them. We're going to learn about ratios. We're going to learn about rates and proportions. Really, it comes down to two things because we've already studied ratios. We've already looked at that lesson. You can go back and review it if you'd like. But so it really comes down now to just two things, rates and proportions. A quick review of ratios. Ratios are anytime you compare two numbers that have the same units or similar units. For example, if I compare two apples with 3 oranges. Now, yeah, apples and oranges are different units, but they're essentially the same item. They're the same topic of subject I'm comparing. I'm comparing fruits. So that doesn't qualify, say, as a rate. It qualifies as a ratio because they have similar units. That's the key. Now, rates are comparisons of two numbers with completely different units. So the theme of the unit is completely different from each other. So if I said, for example, somebody's earning $30 in 1 hour, these units are completely different. This is money and this is time. They're not even related. So we have ourselves a rate. Proportions, on the other hand, are when you take two of these ratios, or two of these rates, and you make them equal to each other. So if I take the money example, and I say this guy's making $30 per hour, which is pretty good money, and I say, okay, that's equal to, let's say, $60 in 2 hours. Because if he's making 30 in 1 hour, then another 30 in the next hour, that makes 60 in 2 hours. And these two ratios are proportionate. Why? Because they're equivalent to one another. Yeah, I know the numbers are different, but they're essentially the same amount of money, just at a different amount of time. So that's what proportions look like. We can do that with ratios. Take two ratios, make them equal, and we've got proportions. Now let's sort these out here into ratios, rates, or proportions. Look at this first one. We've got 6 red bears and 2 orange bears. Right, we're dealing with bears and bears. Doesn't matter what color. That's the same theme. It's the same theme. It's the same topic. So that would be a ratio. How about $40 in a week? Right, they're different. This is money, this is time, so that belongs in the rate category. How about red bears to children? Yes, rate, because the units are completely different. We've got bears and we've got kids. They're not even related. So we can put them under the rate category. Some people could probably start debating this, and I'm not going to go there. I'm going to say that's good enough to qualify as a rate for me. We've got eggs and we've got dollars. Yes, rate. How about this one? We've got 120 students for 3 buses, which is equal to 40 students on 1 bus. Okay, yeah, that's a proportion. And we've got 15 girls to 12 boys. That's going to be what, a rate? No, because we're dealing with essentially the same kind of topic. We're dealing with people, right? Girls and boys. They're probably students in a class. So we're dealing with students here. So that would be ratio. They're the same category, essentially. Same topic. How do proportions help us? Well, imagine you're a flag maker. If you're a flag maker, proportions are crucial to your business. Because if your flags aren't proportionate, then you're not going to sell flags. They're going to look really funny. Let me show you what proportions help us do. They help me make this flag bigger and still keep it looking like the original flag, just larger. It looked like the small flag, it's just bigger. And the reason behind that is because even though this side on the bottom got longer, the side on the side, the width, got higher as well. They grew together. If I shrink it, they have to shrink at the same rate. So if this side here shrinks, then the other side has to shrink as well. Now look what happens if I don't keep it proportionate. What if I do this? Does that look like the same flag? No. You try making this flag and selling it, I doubt you're going to sell very many of them. Okay, because people want to buy flags that are proportionate to one another. So if one side grows, the other side has to grow by the same amount. Let's look at another example. The ratio of width to length of a rectangle is 2 to 5. Okay, great. So we have 2 for the width and we have 5 for the length. Okay, fantastic. Now they want us to build 3 proportionate rectangles. So 3 rectangles that are proportionate to each other, that are equivalent to one another, just larger. So here's what we can do. We can take this here and we can make our first rectangle. Something like that, right? We got our width, we got our length. We can also make it bigger, like this. Let's say I doubled the length. So I put 2. I'm doubling it. Okay. And let me join them for you. What does that mean I have to do to the width? Right, I have to double it. Whatever I do to one, I have to do to the other. And then what's going to happen? I can join this, build my rectangle, like that. And now this rectangle looks identical to this one, but it's larger. But the proportions are similar. Okay, it just looks like a larger version. Look what would have happened if I didn't follow the proportionate rule. If I doubled the bottom, but I tripled the side, the width, if I would have tripled it, so I didn't do the same thing to the other side, they didn't grow at the same pace, then look what happens. So now I've got 3 of these sides stuck together. That doesn't look like this. This looks completely distorted. So let's get rid of this. Let's make it proportionate again. And if I was to write this as a ratio, I would say 2/5, and this would be 2 width, 5 length. This one would be, right, it'd be 4 because I have a 2 and another 2. I have 2 of these stuck together. So I have 4 on the side, 4 for my width. How much is my length? It's going to be 10, right? 5 and 5. So I've got 10 for my length. And these two are equivalent. They are proportionate. That's the word we use, proportionate. They're 2 ratios that are equivalent to one another. And I can make my third one the same way. I can triple each side. I'm not going to do it. You think you get the idea. Here we have an x. We have to solve for x. It's like what we did for fractions. You have to find a pattern. You have to. So we're going to look at the numbers. We have 4 and we have 12. Okay, we could times by 3. Always multiply or divide, never add or subtract. So what does that mean? We do to the top, do the same thing. We get 6. 6 what? 6 cups of water. Now for the bottom, I know what some of you are thinking. I know some of you have found the pattern. You're saying to yourself, this is just times 4. But here's the problem with doing that. What are you going to times here? There's nothing here to times by 4 to get 28. Now some of you are really smart and you're like, okay, well I know 7. If I put 7 here, then I can times it by 4. And get 28. Okay, that would be the right answer. But let me show you where people make mistakes. They say, okay, that's times 4, so I'm going to take 28 and times it by 4 to get my answer. But you can't do that. Because if you're going this direction to get that answer, you're going to the left, you better go to the left on this side too, on the top. You can't just switch directions and times this. If we times the bottom number here, don't times the top number on the other side, is what I'm trying to say. Keep it consistent. All right. So what are we doing here? Essentially, we are dividing. We are taking this and dividing it by 4. That's how we shrink it down. So we take this divided by 4 and then we get 7 as well. See, there's many ways of doing the same question and they all work. It's whatever makes sense to you. Here we have 9 problems coming up and they're going to go by fast. We have, now the reason I'm showing you 9 is because I'm trying to show you every possible scenario that you could get on a test or an assignment so that you do very well. So we have here Samuel earning $87.22 for 4 hours at the grocery store. How much will he earn in 7 hours? Okay, well, here's what we'll do. We'll set up a proportion. We will go 87.22 on top of 4 hours because they go together, 87 with 4 hours. That's the relationship. It's a rate. On the other side, we will say how much means exactly X dollars, we don't know, for 7 hours. And we have to make these equal because it has to be proportionate. He's going to make the same amount of money per hour. So we're going to get now here an X. Now look, what's the pattern? 4 times what is 7? Who knows? It's going to be some weird decimal. I'm going to show you a trick that works every single time. University profs hate this. They will roll your eyes at you if you tell them this strategy. Some high school teachers will roll their eyes at you if you tell them this strategy. But I'm going to teach you because it works. Okay? You still have to understand the other way, but know this one. We cross multiply. You always go at an angle, diagonal. Cross multiply the numbers that are diagonal to each other and then divide by the leftover number, which is right there. To do that, we're going to use our calculator. Okay, just because we've worked so hard without one, now let's use it. We're going to take 7, punch 7, times by 87.22. Equals 610. Now we're going to divide by the 4. Divide by 4 equals $152.64. 64 cents. So we have $152.64. and 64 cents because the 5 bumps up the 3, right? So 64 cents. That's how much he makes in 7 hours. Now, what if you wrote this different? What if you wrote the 4 hours on top and the money on the bottom? Well, that just means you have to flip the other side too so that they line up. See, hours have to line up with hours across from each other and dollars with dollars. Here's a problem I had this summer. I bought some fertilizer. This is a true story. Mr. Melham purchased a bag of fertilizer. The instructions state that 2.5 pounds of fertilizer need to be applied to every 400 square feet. So let's write this down as a relationship. 2.5 pounds for 400 square feet. And I'll just write SQ for short, square feet. If Mr. Melham has not 400, see, it's not a perfect world. Just because the bag says 400 doesn't mean you're going to have 400 square feet. Mr. Melham has 722. 722 square feet. How many pounds of fertilizer does he need to apply? Proportions are so important with this because if you just guess, you may add too much fertilizer and it'll burn your lawn. You don't add enough, your lawn ain't going to turn green. Okay, so you need to keep the proportion the same. So we have now here, we can just cross multiply these. God, university profs just hate that term, cross multiply, because it doesn't teach you anything. But I like it because it works. So we have 722. We're going to multiply across by 2.5. Take your answer and divide it now by 400. Look what we get. We got 4.5 pounds. So I'm going to write 4.5 pounds. That's how much fertilizer, and that will be proportionate to this. So your lawn will look great. Here's a practical one for the grocery store. See, I'm showing you every possible way. It's a lot of questions, but it's worth it in the end. 3 bottles of shampoo. I hope you're writing all this down. Right. 3 bottles of shampoo are on sale at the grocery store for this much money. So let's write it as a relationship. We got 3 bottles. 3 bottles. And on the bottom, we're going to write 422. And that has to be proportional. Now look, it says, what is the unit price? You know what a unit price is? It means the price for just one, right? What does unit mean? Think back to base 10 blocks. We have units, rods, flats, or units, tens, hundreds, all that. So what do units mean? The units are the ones, the little tiny ones, right? So unit just means one. So we need the price for 1 bottle. Where do I write 1 bottle? Top or bottom? I have to line it up on top. 1 bottle. Now we cross multiply and divide, and we will get, now if we cross multiply here, it's going to be a different way. We're going to have to go down this way. Just multiply the numbers across each other like that. Don't times the top number, just times at a diagonal. We got 4.22 times 1, that's just 4.22, divided by 3. You always divide by the leftover number. And we get $1.41 if we round. So we get $1.41 for 1 bottle. That's cheap shampoo. Now look, if you were to flip these around, let's say you decided, some people would have written $4.22 for 3 bottles. Some of you would have done this, and that's completely fine. That just means on the other side, you have to put the 1 bottle on the bottom so it lines up. And then it's the same multiplication. You cross multiply. You still multiply the same numbers. You divide by the same one, and then you get your answer over here again. If there are 6 red marbles and 9 green marbles in a bag, so imagine that, what is the ratio of green marbles to total marbles? We need a ratio now. We're not talking about rates, and we just want the ratio between green marbles to total marbles. Well, look at this. We have 9 green marbles. 9 green. Just write 9 green marbles. There, 9 green. To total marbles. How many total do we have? We have 15. 15 total. That's it. We can reduce it if it, oh yeah, we can reduce it. This breaks down. We could divide this by 3, divide that by 3. You already knew that, right? That makes 3 over 5. So we have 3 green marbles for every 5, well, let's see this. For every 5 marbles altogether. That's all. Now you could choose to write this ratio like this. You could have written it with the dots in between, 9.15. You could write the word 2 in between. It's up to you. Just write the ratio down. That's all they're asking. A store has a ratio of 3-to-1 for basketballs to soccer balls. Okay, so you could choose to write it like this. 3 basketballs, 3B, ... 1 soccer ball, SB, we'll go with SB, And that's going to be equal to, now if there are 221 soccer balls, how many basketballs are there? Okay, what comes first on the second side? Basketballs, right? Because basketballs came first on this side. So you have to write, now we don't know, it's going to be X basketballs, dot, dot, 221 soccer balls. But you know, if you do it this way, it kind of ruins the vibe we've been creating where we're setting up the cross multiplication. So you know what? I'm going to erase all this because I don't like that. I like setting up my proportions in fraction form. So I have 3 basketballs on top of 1 soccer ball. So every time they buy 3 basketballs, they're going to buy 1 soccer ball to go with it. They buy another 3 basketballs, they're going to buy another soccer ball to go with it. And they have 221 soccer balls. How many basketballs do they have? Cross multiply, divide. I don't need a calculator for this. Just going to times this. You're going to get, you could do this in your head, you're going to get 663 basketballs times divide by 1, 663. A rectangle has a ratio of width, comes first, to length. So that's a ratio. See the word 2 in between, of 2 to 5. So I'm going to write this again in a fraction form because it works best. 2 width for every 5 length. If the actual length of the rectangle is 10, so the actual length, look, I wrote length on the bottom. I've got to write it here, 10 centimeters. Now I'm not going to write centimeters. I'm just going to write 10 length. I'm going to remember that it's centimeters. How much is the width going to be? Keeping it proportionate, you set it up like this. Cross multiply, 10 times 2 is 20. 20 divided by 5 is 4. We don't need a calculator for that. So 4 is the width. Now the question isn't asking us that. It's asking us what? Look how I spelled what. What is the perimeter of the rectangle? You know how to get perimeter, right? You got to draw the rectangle. We know that the real rectangle is going to be 4 for width and it's going to be 10 for length. So this has to be 4. This has to be 10. And the perimeter is going to be 10 plus 10 plus 4 plus 4 plus another 4. And you're getting at 28. 28 centimeters is our perimeter. Dan is driving 72 kilometers per hour. You know what per means? It means 1. So we have 72 kilometers. Set it up as a rate for 1 hour. It's a rate, kilometers, hours. They're different units. How far? So far means what? Time or? Yes, kilometers. How far will he drive in 3.5 hours? Look, don't write your 3.5 like this. Don't write a fraction under another fraction. Write it in decimal form. And put an equal sign between them. This is 3.5 hours. Cross multiply, divide. We could really skip the division because we're dividing just by 1. It doesn't change your answer. So it's really just 3.5 times 72. 72 times 3.5. And that makes 252. Holy smoke, that's a big number, 252. Yeah, it makes sense because if he's going 72 in 1 hour, he's going to go another 72 in the next hour and another 72 in the next hour. So that's already like, in the 200s. And then you just add a little bit more. And so it's reasonable. And that's how you do this question. Not too difficult. Now we have 2 to go. You've been doing very well. We have percentages now. We can do it with percent. Look, 75% is the mass. 75% of the mass of the human body is water. So 75% of your body is water. That's just blood and spit and all that stuff inside of you. If Jason's body has a water mass of 122, so his water is 122. We know 75% is water. So water goes with this percentage. We have 75% goes with 122. That's the water weight of Jason. So this is 75% water. This is 122. They go together. We want to know what is Jason's total mass. So you know what we have to do on this side? What does total mean? It means 100%. Very good. 100%. We write it down here. That's his total mass. We cross multiply. Now I know, I'm not going to times, but I know 122 times 100. We'll just have 2 more zeros and then divided by the leftover number, 75. And I get 162 pounds. I get about 162. Let's just round to 163 pounds. That's for his total mass. So that's water and muscle and fat and all that stuff all together. And the last question here, guys, you've been doing fantastic. I'm so proud of you for making it this far. We have 47% of all grade A boys like chocolate ice cream. Chocolate ice cream. That's what they like. 39 boys in grade 8 like chocolate ice cream. So 39 like chocolate. So this percent will match up with that. 47% matches up with 39 boys. So about half the boys then like chocolate ice cream. So how many boys are there in grade 8? Boys who like chocolate and boys who don't like chocolate. Everybody put together. That's going to be 100% of the population. So it's going to be about double this number, right? If half the boys, that 47 is almost half, like chocolate ice cream, and that's 39 boys, then there's going to be about double that amount altogether in grade 8. So we have 39 times 100. That's 3,900. 3,900 divided by 47. And then we get 80, what is that? 82.9. So we can round it to 83. Now, technically, you want to keep it at 82 because you can't have 9/10 of a boy unless they're missing a body part or something. So really, we're just going to say 82 would be more reasonable, but we'll just round it to 83.